impurity here, this impurity, high stress are at the boundaries here. But usually, in the case of air or void, you will have high stress inside the impurity here, and this will make partial discharge, for example.
Yeah, but I think in a void close to the area where you have the electric stress between the impurity and the XLPE.
And this region, between the
for instance, so where you have that circle, exactly in the middle. If you have there a void,
a
shrinking void, then it will be critical, right?
And I think, well, the stress is enhanced by the ratio of the permittivity.
Sure.
So by having an 8 relative permittivity next to a 1, it's worse than having a 2.5 next to a 1.
Exactly. Yeah. Well, I don't fear as such the electrical stress, but as soon as you have a slight
you will have maybe higher stress. Yes.
Yeah. And that might also explain some certain failures in some times.
Any other questions? Yes.
So, because I have the impurities, I know it's impurity will enhance the electric stress. But for the numerical calculation, this results, for example, the absolute value 6.9 kV per millimeter depends very much on the mesh. If you find the mesh of the calculation, do you
Yes.
try to
Actually, I forgot the mesh we used, but we tried many meshes and they all got the same answer.
Are you sure?
Yes. Yes.
In the micrometer range, so I cannot.
I don't recall it in details, but we tried we increased the mesh more to have more accuracy, but it gave the same results. It only had more time of simulation.
We can try it, but I believe it depends on the mesh. It's for this sharp, it's small, very small micrometers. The result very different.
I think if I can add something there, we have found that as well, and one technique that we've always adopted is we would start with this example, do the mesh, and then change all of the permittivities back to one material. So you have the identical mesh in both the reference and the contaminated sample, even with special high concentration mesh around this area, and then it would give a more believable enhancement. But certainly, whenever you get to a sharp point, perhaps you're out by a percentage, 50% risk. Nigel?
Yeah, I want to kind of touch on where Fred was going there. I think one of the interesting things that you've done here with the image analysis side of it is you've got very high stresses, but in very localized regions, and we know that paper, polyethylene, EPR, etc., have the strength increases as we get to very small sections. And I think Fred pointed out there that even if there was a void there, if that's an extremely small void, the peak discharge inception voltages go up significantly. So have you looked at trying to try and perform some sort of volume stress assessment around or in the regions around your contaminants? Because that might actually give you some indication of risk of failure or damage, which I think is where you're trying to go with this.
Actually, I did not do this because it was showing you that this is the biggest impurity here, and it has the highest stress. So maybe there's a relation between the size of the impurity and the maximum stress. But what you know, I did not do. I did not perform it.
Because 6 kV per millimeter is a big stress if you're looking at it over a couple of millimeters, but that's not a big or a high risk of breakdown if it's on a 100 micron or a 10 micron level. And so that's the trouble of scaling that you have with all of these finite element assessments.
Maybe in the future we're...
Perhaps one opportunity for one last question. Right, then I'll ask one. You put a lot of effort into taking an image, converting it, so that your result could be automated. I'm guessing that that's intended that you would use this as a an ongoing quality assurance rather than just an isolated example of, I wonder what the stress is.
Yes, yes. What we have done here is that it's almost like a software here, because if you have different impurities and you have different material, you have only to inject the image of the impurity and the permittivities of the material and the distance from the inner semicon to this one. And then you will have the stresses directly.
All right. Well, I'd like to thank all the authors who are remaining, and if we can thank them all in the usual form. Thank you. Session E7 is closed. Fermé. Mardi fermé.